Today we're here doing the presentation for the Northern Virginia CAD users group, and
Central.
we are with Bricscad, and we are recording this for their purposes. And I'm sorry, Central. Thank you very much, Rich. And we will be doing a short presentation up front. We're recording, and then this will be pushed up to the YouTube site. And my name is Scott Pember. I'm with Bricscad, and we're going to do a short presentation, like I said. And I'm going to introduce my partner and cohort, John Aid, who's going to be going through the product, and we're going to with a special emphasis on point clouds today and a bit about Bricscad. So one thing that we do at the beginning of all of these things, we kind of demonstrate or show you a little bit about who Bricscad is, the producers, manufacturers of Bricscad, and we are a company that is owned by Hexagon. We are a subsidiary of Hexagon, and Bricscad produces computer-aided design software, build an information model in mechanical design and collaboration products. And we've got 2D, 3D types of products and BIM products and mechanical products for consumers out there to use. We're very cost effective. We're going to be much more cost effective than just about all of the other products that are out there, but we also produce a product that yields a whole lot more productivity with the tools that we have, and you're going to be able to see that. Um, Bricscad is owned by Hexagon. Hexagon is about a $4.35 billion organization. We have about 300,000 users over 110 countries, and we are headquartered in Belgium, Benelux area, and we've been there since about 2000, 2001, somewhere around there. And we have offices throughout the world. Sorry, that's my other laptop going. And as you can see here, we've got offices throughout. We've got California, Mexico City. We've got representation all over the globe. Now, this isn't just Hexagon. This is just Bricscad. So this is kind of like a global footprint. As we go through, we've got one of the fastest growing organizations in the CAD market space, design market space. In terms of Hexagon itself, we've got 5,000 R&D employees. This is an unusual number. We put about 10 to 12% of our revenues into R&D. Typical companies only do about 7%. We put a lot of money into R&D. Hexagon produces Leica. We've got different products throughout different industries, which we'll show in just a minute or two. We have about 21,000 employees around the world, and we have strong organic sales growth. So we're not somebody that's just going to be disappearing next week. We've got a strong presence in these core different market spaces, vertical markets, geosystems, geospatial, agricultural, manufacturing, intelligence. A lot of the vehicles that are not being manned by a human being. We have a lot of products that are in that space. Mining is a big area that we go after. So we have a broad array of different markets that we address. And like I said, I'm going to be doing this short part of this presentation. And we can go on to John here real quick. And some of our customers that we have with the product, a lot of strength in the European and the Asian market spaces, and we've just now started penetrating with our products here in the Americas. So here's in the AEC, in the civil space, some of the bigger customers around the globe that use our products religiously. Manufacturing space, we've got a lot of manufacturers, and it's a variety. People from one of our biggest ones here in the United States does third-party aftermarket parts for automobiles, right? So a broad array of customers use our products on a daily basis. Now, with that said, what I'm going to do right now is hand the ball over to my cohort, John Aid, and he's going to kind of run through some of the basics of the product and give you a little bit of background of what we do, and you can have a good look at the product. But we wanted to give you a backgrounder. So, John, it's up to you, my friend. You've got the ball. I will stop presenting right here. And I think you took the screen, did you not, John?
I did. Hopefully you can see it
you're
too.
fast. Good.
Well, thank you, everybody. Thank you, Scott. Thank you, Rich. It's really a pleasure to have this opportunity to present to you a live demonstration of Bricscad Pro and BIM and how point clouds are imported and used for common design and construction workflows. But I'm going to start with a quick overview of how familiar Bricscad is first, and then we'll look at how Bricscad incorporates point clouds into typical workflows. Bricscad is highly compatible with the user interface and user experience that most CAD users know and love. It makes it really easy to learn the product. Here I've got the Start menu open, where you can see tiles for recently opened files. You also have the ability to create a new drawing and pick from a variety of included templates. And of course, you can use your own templates. Also, we have the ability to open additional DWG drawings. We also have a tab here for learning. So if it's somebody new to Bricscad, they can immediately take some tutorials and start to look at some sample drawings. Some of these sample drawings actually show some of the features that are unique to Bricscad, making it really nice to kind of look at them in the context of the drawing environment. And then, of course, we also have a tab here for applications. So we have partners that develop applications on top of Bricscad, and you can explore those by selecting the links here. So we start by talking about workspaces because we do have a product that represents 2D workflows. That is our Bricscad Lite edition. And then we also have 3D workflows, and that's our modeling. And that's our Bricscad Pro. And then we also have a BIM tool set and a mechanical tool set. And they're all built on the same framework. So they're all using DWG, and basically it's all part of one installation, and you just license what products you need. So here are my workspaces for drafting, modeling, mechanical, and BIM, and I can access those in a variety of places in the user interface. The user interface should look very familiar to most people who are users of current CAD products, especially AutoCAD. It's very familiar, delivers the information that you need to be productive right away. That means you have your familiar toolbars. You can access additional toolbars. We have quite a complement of them, just like you're probably used to. We have the ribbon with all the tabs and the panels and the associated tools, and the ribbon will change depending on your workspace. We also have panels over here, or for some people, you think of palettes, and these fly out for your properties, layers, attachments, something called the structure browser, which I'll introduce you to, which is unique to us, and of course, tool palettes. Of course, we have the command prompt. You can tear the command prompt off and float it or dock it lightly to the bottom or re-dock it like most people are used to, and that's the way I'm going to keep it because that's what I like. We have our tabs for each of our open drawings. Again, something that most people are very familiar with, and it hopefully makes it comfortable for you right out of the gate. Obviously, we have model tab for model space, and then we have layouts for paper space and composing your output. We have something unique called the Layout Manager. The Layout Manager gives you a central interface for managing your layouts. You can rename them, you can reorganize them, you can copy them, create them, and delete them here, and you can publish them from here. And of course, we have a status bar at the bottom that gives you access to settings and turning off and on various features like e-snaps and snap tracking. And of course, the command line. It's one of the most important parts of the Bricscad user experience is that commands aliases, and system variables are the same in Bricscad, so you don't have to relearn anything to use Bricscad immediately. So I can type in L and start to get the auto match for things like line and LA for layer and so on. And of course, these can be customized and somebody can bring in their own aliases as well. And finally, probably the most important thing, and the question we get asked the most, is that your drawings are totally compatible because they are DWGs. We work in the DWG file format. They're the same DWGs that you have today, and we can open them, usually can open up files that some people even have trouble with in their own application. There's no translating, no migrating, and no importing. So there's no need to change your drawing templates, blocks, printer setups, or sheet set layouts to move to Bricscad. They are all fully compatible. Sorry about that. So Bricscad is a lot more than just compatible with other CAD applications, because in many ways, Bricscad goes above and beyond what others have to offer. Even in Bricscad Lite, the most basic license option, we continue to innovate both in the interface and in user experience. Bricscad offers unique tools to help you do more in less time, tools that incorporate machine learning and AI-based workflows. So the Bricscad Quad cursor is a context-sensitive AI-based tool palette in a heads-up display right at your cursor. It predicts the command you'll likely need next based on the way you use Bricscad. You'll be seeing a lot of this as I do the live demonstration. We always have a need to rotate, copy, move, and or mirror drawing elements, correct? So with the manipulator, you just hold the pick button a little bit longer and the manipulator appears. It offers all the standard copy and manipulation commands without any command input. I'll be using that too as part of the live demonstration. And the manipulator works in 3D mode. Again, you'll see that also since we'll be dealing with some 3D geometry. The Blockify tool enables you to automatically convert repetitive sets of entities to block definitions. Select a set of 2D entities or 3D solids, and Bricscad searches the drawing for identical sets of entities and automatically replaces them with block references. We support dynamic blocks in that a dynamic block that has been created in AutoCAD can be used directly inside of Bricscad. You can import and access your block libraries from Bricscad's tool palette panels and drag them into your drawings and place them anywhere you want. Once placed, you can edit the custom properties in the Properties panel or grip edit the dynamic blocks like you're used to. And parametric blocks are blocks which contain not only geometry, but also contain metadata in the form of geometric and dimensional constraints and even visibility controls. And we have some additional ones like flip controls and so on. Using this metadata, a single block can represent different sizes and visibility options. This is kind of our answer to dynamic blocks. Even though we can support dynamic blocks, we cannot create them, nor can we edit them. So parametric blocks take over at that point. And we have copy guided, which facilitates the copying of geometry by identifying associated guide curves that help orient the copied geometry to similar curves in a different location. The tool includes the ability to automatically break lines and patterns. Similarly, Move Guided performs a similar function while relocating geometry. Again, with the aid of those guide curves, it automatically repairs the location of an object it was moved from, like we just saw in that brief GIF. So that's the end of my quick presentation on some of the features that are unique to Bricscad. There is so much more Bricscad provides than just the compatible and familiar user experience. And some features like the quad manipulator you'll see throughout the demonstration, and many powerful features for working with point clouds are next. Just keep in mind there is so much more to explore in Bricscad. As many of you may already be experiencing, point clouds are becoming more prevalent in design and construction. Point clouds represent an accurate digital representation of an existing object, building, or site. The point cloud can then be used as a digital twin or basis for new design or to recreate a real-world object. There are many uses for point clouds. In AEC, we can use point clouds as part of a scan to plan, scan to model, or scan to BIM workflow. Today, we'll use the point cloud to view, convert to 2D line work, and then convert to model geometry, including BIM geometry. So we start with using point clouds by looking at our point cloud tab on the ribbon and the reference manager. We use the reference manager to insert a point cloud into our drawing. When we reference a point cloud to a DWG in Bricscad for the first time, it is pre-processed, which optimizes the point cloud, prioritizing those points that are most relevant. So if I kind of go through the process, down here I can either browse to a specific file or a folder of scan files. So sometimes a scan is multiple scans that are registered together, or a single file that's already has multiple scans registered together. If I pick individual file, these are the common file formats that we support: E57, LAS, PTS, RCP, and several others that you can see here. The scan data will be converted to a Bricscad data structure when it is pre-processed. The pre-processing is a background process and partly multi-threaded, meaning you can work in the same or other drawings while waiting for the point cloud to finish pre-processing. From the point cloud manager, I can then insert any point cloud that's already been pre-processed. We're going to use this one of a house. It's 2 gigabytes, and go ahead and insert it. The advantage of it being pre-processed is now I can insert it into any drawing, almost like an attachment, an XREF attachment, and it'll do it almost instantly. And there's our point cloud. Now the point cloud has a control determining what the maximum number of points can be displayed at a given time. By default, it is displaying 4 million points, but we can adjust that anywhere between 500,000 and 20 million points. Granted, some point clouds will have more points than that, but again, Bricscad is pre-processing it to optimize what points are going to be most relevant and most useful when you do attach it into a drawing. We can also adjust the size of these points. By default, we have an adaptive display turned on. What that does is it determines what size to make these points depending on the density of the points in a particular area. The less dense, the larger it will make the points. Higher density areas, it'll make them smaller. If I turn this off, you can see now that, if I turn the adaptive display off, you can see that all the points are the same size, but are denser in some areas than others. I can increase the point size, but it'll increase all the points at the same time, and I can decrease their size all at the same time. We typically use the adaptive display because it optimizes for us the point size without us having to adjust it. Now, point clouds are typically aligned in space based on real-world coordinates and do not typically align orthogonally with our user coordinate system. But the point cloud can be repositioned using regular move, copy, and rotate commands. However, we can more easily align this point cloud using our align point cloud command. And I'm just selecting points that are lined up on a vertical surface like a wall, and it automatically rotates and aligns the point cloud based on that information. Yeah, I think if other people might need to mute themselves, we had a little feedback there.
Sorry, that was me.
Also, once the point cloud is attached, we also have some choices over how we can display the point cloud. So we do have color options. We can view the point cloud based on its elevation, where it will color the points as they move up the Z-axis. We can also show them based on intensity. And again, we can do it using a specific color or a spectrum. I'll do red this time. And what it'll do is it'll be a lighter color red where the points are denser and a darker color red where they are less dense. And again, I can put it back to the typical scan color. Now, when point clouds include more points than are needed, we can easily crop the point cloud to show just what is needed. I'll do this from kind of a front orientation and crop out some of the points. The nice thing about crops is it's not removing anything from the point cloud. It's only controlling the display of points. I have a toggle to quickly turn the crop display on and off. And if I want to totally remove it, I also have another tool to remove the crop entirely. In addition to cropping, I also have the ability to use something called a crop solid. A crop solid allows me to use solid geometry and convert it into a crop. So all I have to do is quickly place a solid in my model, and this is just intersecting the point cloud, and then I can convert it. And this time I'm cropping it so I'm just seeing what's inside that crop solid. Because the crop solid is based on basic geometry, solid geometry, I can also use my editing tools. And notice I'm using this quad to access these tools. I'm not going somewhere else for them, and I can resize this box very quickly just by pushing and pulling on the different faces. And I can select this box and bring up the manipulator and use that to move it to a different location as well. So I can resize it, I can move it around to show different parts of the model, and then I can hide it. And more importantly, if I need to remove it, all I have to do is delete it. Now, crop solid can be used in another way, and that is to crop out a portion of the model that maybe we want to mask so that we can build something in its place. Here I've got a solid already placed on top of a wall. I'll make that into a crop solid. And this time I'll keep the points outside of it. And again, because it is based on solid geometry, I can quickly use my tools to resize it. And again, I can hide this. And now I have a void in my points so that I can create new geometry. So that's a couple of ways we can control how much of a point cloud is displayed. We have one other option, and that is creating sections. So in Bricscad Pro, we have the ability to create sections. We'll do a simple top-down or a plan section. Once it's created, then again, I can select and initiate my manipulator and use that to adjust the location in the point cloud, how I'm cutting through it. Now, if you're not familiar with point clouds or haven't used them before inside an application like Bricscad, you'll notice that there are these green spheres. The green spheres we call bubble views. They represent an individual scan station. So this point cloud is made up of multiple scan stations, but I can access these scan stations by double clicking on the green sphere, and it'll open up a separate view from that scan station. I can pan around in it. It is a 360-degree panoramic view included with the points that it has captured. And I can also change the color representation of this. So this is now representing the X, Y, Z axes in 3 different colors. And then I can also represent depth of field. So as the points get darker in color, they're further away from the scan station, and then I can cycle it back to a normal color view. We'll do more with the bubble views shortly. The bubble views can also, the display of them can be turned off. So if you don't need them, you can basically tell it to turn them off. So a lot of flexibility in how we display, what we show, and how we control the point cloud. Now, let's talk about our unique snap. It's called the point cloud nearest point snap. This allows us to snap to individual points in a point cloud, facilitating tracing over the points with geometry, whether it's lines or surfaces or solids. So I'm going to go ahead and just place a simple dimension to get strike a measurement off of this window wall. So again, I can use that point snap to make it easier to more accurately pick points to get something like a dimension or to start tracing lines off of this elevation. Another way I can generate line work off of this is I already have a section that's looking down on the model, and I can adjust where it's cutting through the model, and I can use a tool that allows me to trace along these walls. It's called Fit Polyline. It's a newer command in our latest version of the software that came out last October. And basically what it does is it minimizes accumulated perpendicular distances to the points of the selected entities. And it works with every type of entity, like regular 2D entities, even text, and even point clouds. So let me go ahead and I need that back on. Just switch our layer. And then we'll launch the command. I'm going to pick the point cloud and then the section. It will reorient my view. I'll launch that one more time. It'll reorient our view based on the section plane. If I zoom in close, you will see these circles which represent points, and then the lines that are connecting them are considered guidelines. They aren't actually drawn. They're just telling me where I can specifically start to place lines to create geometry. I can trace over these lines, as many of them as I want. start to create a plan, if you will, of my point cloud. So if I go and disable my section and turn off the display of our point cloud, you can see those lines that I started to generate. So kind of thinking forward, if I did more of that tracing using the fit polyline, I can get to where I have a lot more of these lines. Again, we'll go ahead and turn off the point cloud. We'll kind of reorient to a plan view. But you notice that even though I was able to trace a lot of lines, they are not necessarily aligned with the UCS. Some of these lines are at slight angles, both horizontally and vertically. There are some gaps where some of these lines should be joined together. And we have a tool to help optimize or clean up this line work. So we can use our optimize tool. By default, it's going to look at the entire drawing, or I can select just what I want to manipulate. I have some settings that control what line work it's going to even optimize. And then I have some tolerances or settings I can adjust. So like the gap tolerance will get some of these gaps, but maybe not the bigger ones. And when I select OK, you can see how the lines are straightening up and even some of the gaps have been closed. Now this gets me a little bit further along to making this, completing this into more of a floor plan. So again, taking a scan and being able to trace it and then optimize it and start using it for a base plan. Now we're going to look at creating some solid geometry. So Bricscad Pro, you can create 3D geometry from point clouds just using direct modeling tools. So I'm going to remove these lines we created. And again, I'm using the structure browser because it makes it a lot easier to pick groupings of entities based on different criteria and then just delete them. Another feature unique to Bricscad. And then I'll go ahead and turn that point cloud back on, and we'll go ahead and cut through it again. And we'll get to a top-down view. So using our polysolid tool, I'm able to generate some wall geometry by tracing around the plan. So I can give these walls a width, I can give them a height, and I can start tracing the wall. And you notice that its justification is based on the center of this polysolid, but I can use my control key to cycle through the different justifications. That is something called the hotkey assistant, which is enabled down here. Again, I can trace out these walls. And then when I go to my 3D view, you can see the walls in the context of the point cloud. And so very quickly, I can start to model geometry and plan and different view orientations. Now we'll take this a step further. So far, we've been doing everything in Bricscad Pro. A lot of this functionality is already there, but I want to use some more intelligence that we built into our Bricscad BIM product. So I'm going to go ahead and change my workspace to BIM. Some of the tools and some of the user interface will change. And if we look at the point clouds tab, we now have some additional tools on the geometry panel, things like detect floors and fit planar and so on. Previously, we created sections to cut through our point cloud. We now can use the detect floors tool to generate sections automatically. It will create those volumes for each floor in the building by searching for regions of points with a similar Z value. And so now I have a section volume for our ground floor and for our second floor or first elevated floor. Now, if we go and look at just that second floor, we can focus on some other features. The point cloud fit planar command is a BIM feature for generating 3D geometry. It will create a planar surface or a solid after a selection of one point in a point cloud. The command works in bubble view and in model space. If the bubble viewer is not open before launching fit planar command, Bricscad will ask you to select a point of the point cloud in the model. So if I do fit planar, and let me go ahead and put my cloud snap on. If I pick a point on the surface of a wall, it will auto detect and start to define a surface. I can decline it and I can pick a point elsewhere, and that's a better selection, and I can accept it. So that has made a surface on that wall. Now I can enable a solid mode. And if I zoom in a little closer, you'll see that there is points representing both sides of a wall on these interior walls. If I pick a point between these surfaces, it will detect one of the surfaces first, and then I have the option of making it convert into a solid. And then I can accept it. So depending on the quality and how complete a point cloud is, I can use fit planar to start to define surfaces three-dimensionally, automatically, and even solids between surfaces that represent walls. We'll go ahead and take these out and look at another way of creating geometry. We can also create surfaces through our bubble views. I open up a bubble view of this room. I think this is considered a dressing room. And I launch the fit planar command. You'll notice that my cursor now has a disk on the end of it and a little axis sticking out of it. It helps me identify what surface I'm actually detecting. And if I pick, it will highlight that surface. While I'm in this command, I can continue to select more surfaces. And I can accept them. If I cancel out of the command, we can now look at those surfaces I just created. But maybe I need the openings for doors and windows. So I'll look at another room. Again, we'll select all the surfaces in the room. This one has a couple more wall surfaces than the last room. And before I accept these selections, I'll go ahead and add openings. And all I have to do is define where those openings are for the window and for the door. And accept it. Go ahead and cancel out of the mode so that when they turn green, that means it's created them. And again, if I hide the point cloud, we'll now see all these surfaces that I created in that second room, including the boundaries for the window and door. And I can use, again, my common 3D modeling and editing commands to project these through to make holes in these surfaces. So again, just another technique for automatically creating three-dimensional surfaces. We'll
Hey,
take
John, this is outstanding. Good stuff. I just wanted to kind of ask, is there any questions on your side so far? I know we have a smaller, more concentrated group, but I know that there was a question earlier before. I think that was answered. Perhaps that was Rich, I think, that asked the question about the bubble views.
Yeah.
Was that we answered that part? Okay.
Oh, yeah. Yeah, you answered that a minute or so after I asked it.
I'm sorry to interrupt, John. I'll let you finish then. Thanks, Rich. I appreciate that.
Yep.
No problem. Again, I'm using that structure browser to make it easier to select the entities I just created, and we'll get rid of them. I know it seems like I'm duplicating efforts, but we're going to do things a little bit differently and take this one step further. So now we've created planes with openings, we've created solid geometry. Now we can actually create a space or define the space of these rooms in a similar fashion. So again, I'm using a similar technique. I'll just do it on one of these rooms just to show you how it works. Again, I'm using Fit Planer. And again, I'm going to start by picking one surface. And like I did before, all the surfaces in the room. Now, before we accept them, we have another option over here called Stitch Surfaces. What this will do is it will create a solid out of these surfaces. It'll stitch them together, enclose them, and create a solid out of them. The advantage of the solid is that it now represents the boundary, if you will, or the limits of that room, which would then be surrounded by walls on the vertical surfaces, floors on the horizontal surfaces, and then ultimately a roof on whatever's at the top. Now, if I jump ahead where I've actually used this tool to create all the solids, it looks something like this. So now I have solids for all the major spaces in this model, all based off of the point cloud and all created using this Fit Planer tool. But this geometry is still a little dirty. Similar to our Fit Polyline example, the faces of these have been created based on the point cloud, and the point cloud may not be 100% accurate, meaning there may be minor inaccuracies, or maybe even the existing facility has some settling and some of the faces aren't exactly true. And because of that, you can kind of see some of this here where they're uneven. We can use that optimize command again on these 3D solids. Again, it automatically detected the solid geometry, or we can select specifically what we want. We have some tolerances we can adjust for the degree that it detects. And then when we hit OK, if you watch this, you will see some of the faces start to straighten up. So it'll both align faces that are adjacent to each other or parallel to each other and true them all up. That's only one step. These solids then can be used to generate the beginnings of a BIM model. To do that, we use our invert spaces. And again, it's going to detect all these solids or masses. Again, we have some settings for the thickness of bottom slabs, top slabs, inner slabs, outer walls, inner walls, and so on, and the degree of parallel and so on. I can even have it do L connections with nearby walls. And when I apply, here's the real magic. It's eliminating those solids that were originally there. It's now placed walls. So if I hover over this, you will see now that it's calling it a wall and not just a 3D solid. So it has also classified this geometry as different things. Sorry, so that's a slab, wall, and so on. And if we turn back on our point cloud and our sections, we can go ahead and see the section through the second floor and see how the solid geometry is lining up with the point cloud. So this is a nice way to automate generating both the geometry, but also the beginnings of a BIM model in Bricscad BIM. Now, the last thing I wanted to demonstrate was a feature that we haven't touched on yet, and that's deviation. I have a separate model for that. This is already has a section that's isolating just one level in this building. This is an older building, but the context of this is that maybe this is newer construction, and once it's built or during construction, I want to analyze the points that are captured in a point cloud against the actual geometry that was used to design it to see how close and how accurate it was once it's been constructed. So I do already have a floor created that I will turn on. We'll pick the deviation analysis tool and pick our target, the point cloud, and my floor slab. And what it'll do is after it analyzes it, it's going to use some tolerances for what's acceptable and an outside range that defines the bad tolerance, and it will heat map, colorize this so that we can now look at it and determine how much of that slab was actually built well, if you will, or is level. And we can change these tolerances too. So maybe I want this to be a tighter tolerance of 3/8 of an inch. 1/2 an inch is kind of a big tolerance. But let's say I do 3/8 of an inch. It will automatically adjust the color map, and it will also adjust our percentages here. So that is the end of my live demonstration. I hope you enjoyed learning a little bit about Bricscad and a little bit more about how we can use point clouds and leverage them within Bricscad. So thank you all for your attention, and I'll hand it back to you, Scott.
You bet, John. That tremendous job. You put a lot of information in 45 minutes right there, and that was outstanding work. I do appreciate everybody here that has joined us. And I'm going to real quick turn off the recording for us and this session right there, and stop the recording right there.